Welcome to February 7th LeetCode Challenge. Find the difference. You're given two strings, S and T. String T is generated by randomly shuffling the string S, then add one more letter at the random position. Return the letter that is added to T. So we're given the example here, S and T, and then we can find the difference. By inspection, we know that E is the character difference between the letter was added into T from S. Likewise, example number 2, we have S being an empty string and Y being a T being a string of Y. So therefore, the only thing remaining is Y. That's pretty much it. The length of S is basically between 0 to 1,000, and then obviously if you add one letter character to T, then T would be the size of S plus 1, where S and T consists of lowercase English letters. So intuitively, what we could do is basically sort both arrays, right? Sort S and sort T, and then find the difference or return the last element. So basically, what we could do is something similar to that, just intuitively. So S and T would be, you would string join an empty string using the join function. You sort it S. And then you would also define, so S would be the string join function of the sort S, and T is going to be the string join function of join sorted T. And then once you have S and T sorted and joined together as a character, we're just going to iterate through the length of S, or T minus 1, for I in the range of length of T minus 1. What we could do is, if the string S at index I is not equal to the string T at I, then what we could do is we could return T at I, right? That's the case for right here. So if S is not equal to T, therefore just return I. That would be T at I would be Y, right? And then we're going to take care of the case where it's last value here as well, or any value that's different. Return T at -1. Alright, so this is a big O of, let's submit it, big O of N time complexity. For memory complexity, it's actually a lot larger actually, because it's using the sorted function. Sorted function is, I believe, big O of n log n for time complexity, and that's why the time complexity is pretty low here. Memory is pretty good because it's using a constant memory. So this is one way of doing it. Basically, sort S, sort T, iterate through it, and find the difference. If there is, if it's not equal, then return the difference. If it is all the same, then just return the last one. That's pretty much how these two are given. So this is the method using sorting and character comparison. Pretty easy. However, there's another way of doing it, using bit manipulation. So let's say if you have a little bit of knowledge on exclusive OR operation, so characteristics, what we want to do is, if we were to take the XOR of 0 and let's say XOR with X, that would give us a same character. However, if you XOR it with the self, exclusive OR X, then you would get 0. Right? This is the XOR function, that characteristics that we need. Actually, no, X, yeah. So for any character X, if you XOR it with 0, we get X. If you XOR it with itself, we get 0. So from this knowledge, we can actually find the different character in it, because if we XOR 0 to both string S and T, then the last value would be the ASCII character difference in the ASCII character. So this is a little bit more creative. I kind of enjoy this question a bit more. So let's say you have an output equal to 0. So for I in the range of the length of S, what we're going to do is update our output to be output. So we're going to take the XOR with the ordinate number of S and T. So to do that, it would be this character, the caret character, take the ordinate of S at index I, XOR with the ordinate of T index I, and then what we want to do is take the output, and then we want to basically do a ordinate of its output with ordinate of T minus 1 index. Then return the character of the output. So basically what we did was, so if we XOR the output, which is going to be 0, with a value that is the same, if they're both the same, then we're going to update the output to a specific character, the value, right? And if we know that it's a 0, then we just basically XOR it with the last index, right? So then we should keep on doing this over and over until we get the so that'll be the last ASCII value of the difference of the character. Then we just convert it back to a character, and then let's run this and see if this works. For I in range. All right, similar idea here. Let's run this. Okay, this one's a little bit better in terms of memory complexity and space complexity and time complexity, because we do a big O of n notation here, and we still return an output, but we do character conversion. All right, there you go. Have yourself a great day, guys.